try and be mobile. Let's see though. All right. So let's go to notes. You guys in here can close the Chromebooks if you want. Okay, so we're going to graph sine and cosine functions. All right. So to start, these are called periodic functions. So if you see something like that pop up on like an SAT type question, all right. Periodic means it repeats. It's called a period that it repeats over. All right. So there's an interval where the graph will repeat itself. So in this one, all right. So with sine, it's going to repeat. Oh, too much cheat sheet. Over this interval where I'm drawing the blue bars right now. All right, that's the shape of the graph that repeats itself. So this right here is the copy paste. Infinitely amount of time, right? So if I take this little wedge right there and cut it out and put it on top of there, it's symmetrical, lays on top of itself. All right, we call this the period of the graph. All right, and there's a formula that I'll give you to you in a minute, but that's where the graph repeats itself forever, left and right. All right, so once you figure out what that period is, and if you don't have decimals or something like that, once you figure out the period, it's really easy to just duplicate the graph forever. And then we have something called the amplitude. All right, so that's basically the height of our little mountains here. All right, we shift the color. All right, so from where the graph starts to the top, this is called our amplitude. So for amplitude 1, that means from the origin up is 1, origin down is 1. The amplitude is 2, it's 2 units high, 2 units lower. Total height would be 4. So we got our amplitude, and we got our period. Amplitude is how tall it is, half the distance between the minimum and maximum values, right? And the period is where it repeats that. So we're shifting from degrees, talking to radians now. So all these graphs will be in radians. I'm going to pull up Desmos, and I'll show you that as well. All right, but everything on these graphs will be in terms of pi. If you hate it, you can convert it to decimals, but I think once you do a few of them, it gets easy. All right, so that's a sine function. Cosine is basically the sine function shifted before it starts. All right, and we talk about these functions. The real life application is like radio waves. All right, radio waves are periodic functions, so they repeat. You know, obviously, you see people in movies, they dial them in. All right, so these functions are used radio waves, I guess, then like cell phone towers, stuff like that. So this, you know, if you become a huge geek, you could get involved in that kind of stuff. All right, so for the cosine function, from here to there, the blue, that will be my period. All right, we can see where it repeats. I can see where it repeats. And then our amplitude is, depends where I'm draw. I'll draw off to the side here, is right from the origin line or x-axis to the top. All right, so visually speaking, that's what those two things are. Amplitude is half the whole like dip. And our period is when does it repeat? Yes, so here to here be the amplitude.
I mean, like the middle one. That one.
That's from here to here?
Yeah.
Yeah, that would be too. I just didn't want too much in one little spot. All right, so the period, technical terms, all right, it's the length of a cycle. You can start at any point on a graph. So for today, we're just talking, base. We're not shifting. When we start shifting the graph, it starts in different spots. Shift left to right, shift up and down, but these are just they'll look the same. They'll either be compressed, so the period will repeat a lot faster, or it'll be stretched out where the period repeats in a longer period of time. All right, and our amplitude will either be really high or it can be really short. Okay, so it could look like really fast repeating, or it could be really like slow, like waves of the ocean. All right, like tides. Tides are periodic, how they repeat themselves through the moon cycles and the time of day and everything. Then you have your amplitude. All right, and this is half the distance between the min and max values, like I was saying earlier. All right, so tiny written in there, the next part. All right, we're given the base form of functions without the h and the k. Again, we'll add later. All right, but the number in front of sine is a, and it'll always be at least 1. The number in front of x we'll call our b, and again that would always be at least 1 or negative 1. So to calculate what the amplitude is the absolute value of a, because it's height. So height always has to have like a positive value to it. You can't be negative 3 meters tall. All right, so that's why they slap the absolute value on it. All right, and then our period will be 2 pi divided by b. All right, so for the first 4, just a quick little warm up. Let's identify the amplitude. Let's identify the period, and then I'll shift to Desmos. I think it's easier that way to see it and then translate it. All right, so for our first one, we have sine of 4x. So let's label what's a for this problem. A is in front. Yes, it's 1. If there is no number, it's 1. And then our b is 4. All right, so the amplitude, just abbreviated as amplitude, is equal to the absolute value of a. Write it out. The long way to start. Then we can shortcut it in a minute. The absolute value of positive 1 is 1. That means this graph, let's sketch it, right? Got my graph. Go by 1, negative 1. That means our waves, not talking about period yet though, my waves will be in between 1 and 1. Won't get any higher or any lower than 1 or lower than negative 1. All right, now the next part is the period. That is 2 pi over b. All right, so b is 4, so we'll just do 2 pi over 4. And then this fraction simplifies to what? Pi over 2. Yep. Pi over half pi over 2. We have pi over 2. So, quick sketch over here. All right, let's say the graph goes in intervals of pi. right, so in between 1 pi would be half pi, and then so half, 1, so 1/2, 2/2. This would be 3/2, 3 pi over 2. All right, so that means our period, the graph repeats. No, it's a short graph. All right, so our graph will look something like this. All right, not a good sketch, but it's kind of the gist of it. So the repeating part, whatever that is, gets copied and pasted every half unit throughout the graph. All right.
So,
Yep, that's it. Yeah, don't take it out in terms of pi, leave it in terms of pi. All right, and then let's number 2, our amplitude is the absolute value of A. So A for this one is what? That fraction in front of 7/2, which is 3.5. Either or, so 7/2. That means my B is 1. All right, so the amplitude is the absolute value of A. This is the absolute value of 7/2. It's just 7/2. All right, so it means the height of it is 3.5 units above the x-axis and 3.5 units below. And our period is 2 pi over B. And B is 1. It's always nice when B is 1. Makes the math easy. But it's 2 pi over 1. Which is 2 pi. That's a standard graph, so that whatever the chunk is between 0 and 2 pi, that will repeat every 2 pi. Then we have cosine. Now these get fun. When B is a fraction, a little more work to do. So A is -5. And then B will be 1/3. Amplitude's always cut and dry. It's easy. So it's absolute value of -5 is 5. All right, the period is 2 pi over B. So this is kind of what I was helping you with yesterday, alumni. That math will come back in again. So it's going to be 2 pi divided by 1/3. So we can't divide fractions. All right, so what we have to do is you got to take the denominator and flip it and multiply. So this becomes 2 pi, and I just take the numerator and I make it into a fraction. So 2 pi over 1 times, flip the denominator, that'd be 3 over 1. So our period is 6 pi. So this is a really long, stretched out graph. Okay. All right, last one of these. Oop, jumping the gun. So we get A is -2, B is 4/3. The amplitude for this one is going to be what? Yep, +2. Period. Yeah, solve it out. It'll be 2 pi over 4/3. Let me know what you get. Yeah, go ahead, ask. Fire away. All right. So 2 pi over 1 times the reciprocal of the denominator will be 3 over 4. Yeah, only flip the denominator. And then you can cross simplify if you want, but let's just multiply the top and multiply the bottom. So 2 times 3 will give me 6 pi in the top. 4 times 1 gives me 4 in the bottom. And then you simplify this fraction here. 2 goes into both of them. So it becomes 3 pi over 2. All right, and that is somewhere in the middle. So I think the toughest part about graphing what's coming up next, and what I struggle as well with graphing these, is figuring out what's in between. So you got pi, you got 2 pi. Sometimes you get like fourths, sometimes you get 80. Times 3.
Oh, you're multiplying.
Yeah, no. Across. Fractions multiply, top, bottom. If there's an equal sign there, then you do that cross multiplication. I'm going to stop presenting from here. I'll pull it up on the Chromebook. So, for me, it's easier to type it in the Chromebook or a computer than it is to put it on the iPad. All right, so first graph. All right, you don't have to type the f of x in. So all you got to do is type in 2 and then sine of x. We get our function. Thing with Desmos, though, what you have to do is Desmos gives it, you see, numbers, right? So you got 2, 4, 6, and 8. We have to force this to be in radians. So this is probably the tough part, but once you do it once, if you save the graph, you can just come back to it. So what I'm going to do is I'm going to change the graph settings. All right, make sure it's on radians now versus degrees. We're on radians because it's in terms of pi. Anytime you're using terms of pi, it's always radians. Anytime there's that degree symbol, we use degrees. All right. I'm going to keep my y-axis the same, but I'm going to change my x-axis to -2 pi on the left. I'll just type in -2 and open up the Desmos keyboard. That gives me pi. And on the right-hand side, change this to +2 pi. It gives you the decimals, all right, numbers. But I want to see it in terms of pi, so I need to change my step to, I'll do pi over 2. Pi divided by 2. You guys here. negative 2 pi, 2 pi, and then your step pi 2. And what I would do, all right, so you don't have to do this every time. This sucks to do it every time. It takes a couple minutes to do it. All right, so then just log in to Desmos with your Google account. And then all I do, I'll change the name of the graph. I'll just call it trig functions. And I save it. So anytime I just want to graph exclusively trig functions in Desmos, I would just click. I got a ton of graphs saved over here, but I would just go in here and I would click the graph that says trig functions. So I got a ton that I can do template, but that's straight back. All my settings are saved, and you don't have to keep going back and forth.
How do you change degrees to radians?
Press the wrench. It should already be in
Sorry, it's a radian.
it's already in radians. All right. Time we have 7. All right, so we're in radians. Just leave it alone. All right.
We have to. Really draw.
Yeah, let's fill in a little drawing. Trying to figure out how to explain it with having both things up. I'll go back to presenting here. Yeah. All right, so what's going on? So I got it up here so I can reference both. My amplitude for this is 2. My period is 2 pi over b. B is 1, so my period is just 2 pi. All right. And then you can see, if you still have Desmos up, you can see that your height is at 2. So the highest it goes is at 2 on the y-axis. All right, so I know I'm going to start at 0, 0. All right, so I place my first point at 0, 0, and just kind of transcribing off the graph here. The next unit of measure that pops up is at pi over 2. But on the graph here, there is no pi over 2. Then there's pi and 2 pi. So if you just, there's 4 grids, right? So just cut it in half.
You gotta go.
All right, just go in the middle, and you can call this one, I'll use the black thing.
It's like right.
Yep. So in between 0 and 1 is pi over 2, and we'll add the other one in between. If you think about it in terms of halves, right? This is 1 half, pi is 2 halves, so the next in between would be 3 halves, and then 4 halves. Think about it in terms of halves. So then in between here will be 3 pi over 2. And then that'd be the same thing on the opposite side of it. So I'll have negative pi over 2, and then negative 3 pi over 2. All right, so looking at that, I know it's 2 units high. Looking at Desmos, it tells me that pi over 2. When it touches 2 again, so it always goes up, and then it'll come down, down, up, up. Kind of how the wave of it goes.
2 pi over 1.
Yeah, it's 2 pi.
No, it's about black one. Oh, that's not the day I think.
This one is negative 3 pi over 2.
Those are all 3 pi over 2.
So pi tick marks bigger, so negative 2 pi, negative 3 pi over 2, negative pi over 2, 0. That's like tick marks. Okay. And it's the same thing on the other side, just positive. All right, and then if you look at Desmos, you see then it crosses the x-axis at pi. And then we hit the amplitude again at 3 pi over 2. My amplitude is at -2. And once, I feel like once you get this first curve, you can kind of see where it starts to repeat. Right? So we went up, we came down, we came down. Now we have to go back up. Once you hit the amplitude line, you have to come back up. So I'm going to come back up. Count tick marks. I went 1, 2, up 2. And I went 2, 2. So let's go right 2 units and up 2 units. So we hit it right there. And the graph looks like that. So that'll repeat to the left and to the right forever. What we just drew here, where it drew blue, is the period of that graph. All right, so I'll cut it here. We'll pick this up again on Tuesday. We'll do the sine, cosine, some more of these. No homework. I'll change the date of that in classroom. All right, so no homework. Enjoy the weekend. I'll see you all on Tuesday. If you do it here in class and I see it, I'll just check it off and I'll send it to you. All right.